Okay, so why don't you try and answer the problem, pause the video, and then after you've given an attempt, when you're ready to continue, press play and we will try and go over the problem together. Okay, so a certain experiment has three possible outcomes. Okay, so you know that there are three possible outcomes. Outcome 1, let's call outcome 1, outcome 2, and outcome 3. Now, the outcomes are mutually exclusive. And what mutually exclusive means is that they don't overlap. If 1 happens, 2 and 3 can't happen. If 2 happens, 1 and 2 can't happen. Same thing for 3. If 3 happens, 1 and 2 can't happen. Alright, so they have probabilities that are respectively p, p over 2, and p over 4. Okay, so what is the value of p? Okay, so whenever you have some sort of outcome, there's always going to be a proportion of 1 as the total, right? So, I mean, if you have a 50-50 chance for a coin, right, a coin is going to have a 0.5 chance of landing heads, a 0.5 chance of landing tails, and if you add the outcomes of heads and tails, you get 1, right? And these are also mutually exclusive events, right? If heads happens, tails can't happen. And in, the other way around, if tails happens, then heads can't happen. Alright, so if tail happens, can't happen. Okay, so that's the whole point. So what we're basically saying there then is we have a very similar situation, except we have three events. Alright, so what we have is we have a situation where event 1 has a probability of p happening, event 2 has a probability of p over 2 happening, and event 3 has a probability of p over 4 happening. And there's no other possible outcomes, right? It actually has only three possible outcomes. So we have these three outcomes. In total, they will accumulate to 1, and they're mutually exclusive, which means that they don't overlap. So you don't need to worry about double counting an event. All right, so double counting an event would be if you have two events that could happen, A and B, and A has an event space like this and B has an event space like this, there's a situation where both A and B can happen. And if that occurs, then what you need to do is you need to find the probability of A. You need to add that to the probability of B. But then you also need to subtract the probability that you have both A and B. Because when you add A and you add B, you're double counting this section. So you have to subtract this section afterwards. So that's why you do this. But if you're mutually exclusive, you have two events or three events or four events, and there's no overlap. So you don't need to worry about this. Alright, so this is what we're trying to solve. Alright, so first what we need to do is we need to, what we could do is we could just create a not common denominator, and I think that's what we'll do. We'll just say this is p over 4, so we're going to change this to 2p over 4. So this is p over 4, this becomes 2p over 4, and this is p. So we need to change this to p over 4, so we're going to multiply it by 4. So that's 4p over 4. Right, so it's the same thing as over here. I've multiplied this by 4 over 4, and I multiplied this by 2 over 2. And you can do that to anything. You multiply anything by 1 or the equivalent of 1, right? So that's what we did, and that's going to be equal to 1. So now we can bring these together, which is going to turn into 4p plus 2p plus p over 4 equals 1. 1 is equal to, just add these up, 4, 6, 7. 7p over 4 is equal to 1. P is equal to 4 over 7. So this is what we're looking for our final answer. This is what we're looking for our final answer.